So like I was asking, where does it point towards? So, you have the right hand. So, velocity is pointing towards the x direction. The magnetic field is pointing towards the plus c direction. So like this. And look where the cross product is pointing towards. It's pointing towards the minus y direction. Now, we know that the electric field which will point towards the same way as the magnetic force will point upwards. Therefore, we can already presume that on the upper part of the block there will be negative charges building up, and on the lower part there will be positive charges building up. So we can already presume that the voltmeter will give us a negative reading. Now the calculations will be performed in this following way. With knowing that the electric field will be given by the perpendicular voltage and the height of the block. So the magnitude of the electric force will be this ratio multiplied by charge. Then the current will be determined by Ohm's law, and the velocity can be determined in this way because of the presumption that, since it is from the presumption that velocity, because of the relationship based upon the relationship between velocity and the current. The resistance can be calculated with in this way, by taking the area of the cross-section, the cross-sectional area of the block. The cross-sectional area will be taking a slice of this smaller face. And so we will just do the calculations. Remember, this is an I, it's not a 1. And after determining all this, we all substitute out HW, because we're going to take the smaller face, the area of the smaller face, and this will be the way that we will get this velocity. And afterwards, we can get the magnetic force in this way, and once we can isolate the whole value, we can get the calculations for it. But remember, we need to take into account the perpendicular voltage, because the ammeter, the voltmeter, is connected vertically, not horizontally. Therefore, we can get the value being this number, which will be all when you plug into all the data from the given problem, and then we get this number as a solution. Then, how do you determine the current? Remember the minus because of the terminals. Now, how do we get the current? I was saying before, we get the same equation that we had before, but we know already the parallel voltage. We know it because it's the battery. And once we get the parallel voltage and we do this ratio from before, and we plug into all the numbers, we get I equals to 2.2 amperes. But the ammeter reader will be positive because the current, think about it, the current is flowing. The parallel electric field is flowing in accordance with the flow of the charges. It's got to go from positive to negative because the electric field always points towards the negative terminal. But if you see it, this side of the charges, or you can notice that this terminal is negative and the other terminal is positive. And you can notice that the charges, when the way they're moving, is from positive towards negative, from positive to negative. And because the movement is going in accordance to the movement given by the ammeter, we can conclude that the reading will be positive. The main reason why I messed up with this question was mainly because I misread the question. I thought that it was just asking me for the sign of the reading, when what it was actually asking me was for the actual amount of the voltage and the actual amount of the current. And this is my exam wrapper. Thank you for watching.